for 71 minimum number of operations to sort a binary tree by level. I think the description is very straightforward. So we are giving the root of binary tree with unique values, and in one operation we can choose any two nodes at the same level and swap their values. So we're going to return the minimum number of operations needed to make the values at each level sorted in strictly increasing order. Yeah, so the level of the node is the number of the edges along the path between it and the root node. Normally, if you read this kind of description, you should understand what is the meaning. Let's just try to use an example 1. So for the first example, we have the root node, it is 1, and how many operations? So for 4 and 3, it is 1 operation, and in the third level, we're going to find 7 and 5, it's going to be shifted with each other, and then 7 and 8 are going to be shifted with each other, so in total there are going to be 3 steps, so we're going to return a 3. And I will not explain the second example, but the idea is just like that. We need to get the value of the node in each level, and we need to calculate how many swaps. And we definitely want to calculate the minimum number of swaps. Yeah. So for solving this problem, we need to use some mathematics skills. So in mathematics, the skills is that, let me just use an example. So for example, we have an array, and inside array it's going to have 3 values, 0, 1, and 2. And those 3 values have already been sorted. So what is the minimum of swaps? Definitely it's going to be 0. But how can we calculate it easily? But sometimes it cannot be 0. Maybe it is 1. It is 1, 0 if we only have 2 nodes. Yeah. Or maybe if we have 3 nodes, it's gonna have 1, 2, and 0. Yeah, we have different kind of combinations. So the idea is that if we have a 1, 0, 1, 2, it means everything is sorted by itself. 0 is sorted, 1 is sorted, 2 is sorted. And for this 1 and 0, 1 and 0 is not sorted. Definitely we need to swap it, swap 0 and 1, that it become 0, 1. Yeah. And for the third example, definitely we need to swap all of them to make it 0 like 1 and 2. But exactly how can we make that? So in mathematics, we can use the cycle shifting. So the cycle is that we need to find a cycle first. So for the 0, we cannot find the cycle because 0, the index is 0. We're going to use this index to find the cycle. So the index of 0 is 0, it is itself. So the cycle is itself. For 1, it is itself, and for 2, the cycle is itself. But how can we calculate? So we're going to use the length of the cycle minus 1. So the cycle is going to be 1 minus 1, 0, 1 minus 1, 0, and 1 minus 1, 0. So for this one, the result is going to be 0. And for the second case, because it is a 0, 1, so we're going to first use the index 1 to find the position. It's going to be here. And then we're going to use the index 0 to find the position here. Now we find a cycle. So 0 and 1, they are cycles. So for the cycle, the length of the cycle is going to be 2. So the final result is going to be 2 minus 1. So we're going to need a minimum of 1 swaps. And for this example, 1, 2, 0, because the value 1 going to be the index 1, and it's going to be ported to 2, and 2 going to be ported to 0. Yeah, because the index 2, it is 0, and 0 going to be ported to 1. So it seems 1, 2, 0, it becomes a cycle. Yeah, so let me make a drawing. Basically, it is like that. Yeah, 1, 2, 0. If we can find a cycle, definitely, because all the values are unique for each of the level, definitely we can find a cycle. If we can find a cycle like that, definitely the answer is going to be the length of the cycle minus 1. So the length of the cycle is going to be 3 minus 1, it's going to be 2. Yeah. So this is exactly how can we solve it easily. And the time complexity is going to be n log n. And n going to be the number of nodes. Let me just check how many nodes. So it's going to be 10 to the power 5. Maybe this is going to be the best way to solve the problem. If you use maybe select sort, maybe that's going to be n squared, you cannot solve it. I'm not sure, but definitely we're going to use a better way to solve it. So that is this kind of idea. I'm going to call it cycle shifting. So if everything is inside a cycle, they can shift each other to continually to let it become cycle. We just need to check the length of the cycle. Yeah, because 0 to 1, 1 to 2, and according to this kind of calculation, definitely the swap going to be the length of the cycle minus 1. And sometimes it has already sorted by itself. For example, 0 has already sorted, 1 already sorted, 2 already sorted. So the cycle going to be itself. So the length of the cycle minus 1 going to be 0. So for this operation, the swaps going to be 0. So this is why, because each of the cycle is independent with others. Because this cycle is independent with the cycle 1 is independent with cycle 2, and similarly for this 1 to 0, it is a cycle. Maybe we have another one, maybe 4 and 3, so it's going to become another cycle. So they are independent with each other, and we can calculate them separately. Yeah. Now let's just try to use this kind of idea to solve the problem. First of all, we're going to prepare the level order traversal. So inside, I'm going to prepare a root. I'm going to prepare the patterns for the level order traversal. So I'm going to prepare the level array, and then I'm going to loop through it. So for anything in range, length of the queue, I'm going to pop out the node. It's going to be the queue dot pop left. Yeah, and then I'm going to check it. So queue need to append the node dot left, and then I'm going to check the node dot right. So queue need to append node dot right. So this is just the level order traversal. So we need to put the node inside of the level, but we need to put the value of the node, node dot value. Now we have a level array. We need to put it inside of our final result. So I'm going to prepare a result. It's going to be unprepared check function, and inside it's going to be the level. And finally, I'm going to return the result. Now let me just prepare a result variable. Yeah. So currently we just need to use this check function, and inside the level it's going to be the values of each level of the tree. Now we just need to calculate this check function. Yeah, we just need to check how many cycles. Let's just prepare a check function. I'm going to use a as the array. Now, because all the value, maybe for the first level it is 1, for the second level it is 4, 3. Yeah. So in order to make the calculation easily, I want to turn the 4 and 3 to be 1, 0. Yeah, so I want to make it continuous from the 0 to n minus 1. So if it is like 4, 3, I want to turn it to 1, 0, definitely. Yeah, so I'm gonna use a sort. So A gonna be sorted range of length A, and I'm gonna use a lambda function. It's gonna be I with the index, and it's going to be AI. So in this way, definitely we just prepared some values like 4, 3, 2, 1, 0, because in this way it is easy for my next step calculation. Yeah. Now I can calculate it directly. I have this kind of array A. It has already been prepared like from 0 to n minus 1. I mean inside the values, because definitely I want to use the index. I also need to prepare a weighted set, because if something is inside the cycle has already been weighted, I don't want to weight it again. Otherwise, there's gonna be a infinite loop. So I'm gonna prepare a set. Now I'm gonna loop through all the values inside the array A. Yeah. So if n is not inside the weighted set, so the weighted set gonna add this value. Yeah. Now what I'm gonna do? I'm gonna update. Yeah, but I cannot use if. I need to use while check to get all the possible lengths of the cycle. So from here, for any value n inside the array A, I need to prepare a counter. So this counter gonna be record the length of the cycle. So if it is not inside my code, gonna update to 1. And I'm gonna update it to the next index. So the n gonna be equal to a yeah, and this n gonna be equal to an, And finally, I need to check the count. If the count is more than or equal to 1, so my final result, let me use answer maybe. So the answer is gonna plus equal to count minus 1. Finally, I want to return the answer, not result. Yeah, now let me just prepare a variable answer. It's gonna be 0 from the beginning. Yeah, I'm not sure if you are familiar with this kind of code. Definitely this code is cycle checking, because inside the array, for example, it is 1 0, so we're gonna start from this 1. So as this is index 1, it's gonna be go to here, so 1 0 and then 0 to 1, but there is a cycle, so we're gonna stop it because n is should not inside the visited set. If n is inside, we're gonna stop it. Now we have a count of 2, so if this count is more than or equal to 1, so our answer is gonna plus equal to 2 minus 1. It's gonna be 1. Yeah, I think everything is finished for this kind of coding. Let me just run it to check. Yeah, I did something wrong. I don't need to use as while n not in visited set. Yeah, because as is just for checking. And now, as you can see, it works. Now let me just submit it to check. Yeah, as you can see, it passed all testing cases, and it's pretty fast because the time complexity is n log n. So why it is n log n? Because here we have the sorting. So this is n log n time. Yeah, even though inside its level it is much less, the length of the array is much less than the value of n, but in total I gonna, yeah, maybe the maximum length of the array gonna be n, so we're gonna check it as n log n time for this kind of a problem. Definitely for here this is all n, and for here this is n log n, so that is why the time complexity is n log n. I think the difficult part may be concerned about these areas. Yeah, because everybody know how to use a level order traversal to put it inside the level array, but the difficult part may be, can we think of this problem as a cycle, and then we're gonna use the cycle idea to find what is the minimum number of swaps, and then we're gonna use this kind of a setting. So the array A gonna be sorted from 0 to n minus 1, because this is easy to calculate for the next step. So for example, n equal to an. Yeah, this is also important, and this is also important. So yeah, normally if we want to check a cycle, we're gonna use the while loop. And I think that's all about it. Thank you for watching. See you next time.